Have you ever wondered how those applications change the country's origin and even the language in it based on where you open them? Well, in this video you'll learn how. So here is an example. Let's say you want to open Samsung.com. You write Samsung.com and then you enter. It redirects me to the Italian page. Basically, I will have lower latency because the servers of Samsung is going to be near Italy, and also the language changed to Italian. In case I want to change it to Spanish, let's say, we can write ES and then redirect us to the Spanish server, and even the language is Spanish. So probably Samsung is using CloudFront for content delivery network by Amazon. So let's see how that works. So here we are, same as the previous video. This is one of the questions that you're going to see on the Solution Architect Professional exam. Let's start. The problem stands. You're a cloud engineer at a software company. The company has drastically increased their customer base around the globe, and a lot of users are complaining about the latency of the application. Your CTO has asked you to find a solution to reduce the latency of the application by deploying the application in multi-region and redirecting the users to the nearest region. The solution to this problem is going to be as follows. First point is going to be store static content in S3 bucket and use CloudFront to distribute the content and increase the cache time to reduce the latency. The second point is going to be use Lambda@Edge to redirect the users to the nearest region based on the location of the user. So in this video, we're going to see a real hands-on project that we're going to deploy Lambda@Edge and CloudFront. So this is the architecture. We have an AWS account and we have multi-regions. It's going to be N.Virginia, Frankfurt, and also Singapore. The application is going to be hosted for the static content on an S3 bucket, and for the dynamic content, it's going to be just a simple Lambda function and fronted by an API gateway. So the same dynamic content is going to be deployed in multi-regions, and all of them are going to be fronted using CloudFront. So whenever a user makes a request on the CloudFront, based on the header CloudFront viewer country, the Lambda@Edge will redirect it to the nearest region. So in my case, on Italy, it's going to redirect me to the Frankfurt region. So let's see our configuration files. Let's start by the website. The website is going to be a simple static one. So all it does is such a wonderful website. The website is stored on unknown region. So it is a component of HTML, CSS, and JavaScript, and it calls the API path on the host itself to find the region. Now, this is going to be triggering a Lambda function. So the Lambda function is going to be just a simple Lambda code that responds with a region. The region is going to get it from environment variables. So when we are going to deploy it, each region is going to have this environment variable of region, and it will respond with it. So the application is complete. Now, I have specified a Lambda module that creates all the components. So basically the role of the Lambda, API gateway, and all the routes to the Lambda. Let's have a look. So the IAM role for the Lambda policy attachment, the API gateway v2, and the protocol is going to be just a simple HTTP API. Permission for the Lambda to get triggered by the API gateway, the integration, which is going to be an AWS proxy, redirecting to Lambda, the route on proxy plus, and the stage, which is going to be just a default one. And also an archive data just to zip the file which holds the Lambda function. This is the module that we're going to deploy it over and over in 3 regions. And this is how we call those modules. So module Lambda US East 1, for each region we are going to call this module, and we are going to insert the provider of the alias US East 1 and EU Central 1 and AP Southeast 1. The variables that we are going to insert are the region, which will be as the environment variable on the Lambda itself, and also a prefix. Let's see the static files that are going to be deployed on this S3 bucket. So the S3 bucket component, a policy that allows this CloudFront distribution to get the files, so get object policy, ownership controls that it is bucket owner preferred, the objects, which are website index.html and the CSS and JavaScript component, and that is all for the bucket component. So let's have a look on the CloudFront resources. Main.tf. We create an origin access control so the CloudFront can get objects from S3 bucket. We create a cache policy for the CloudFront, which we set up the maximum TTL as much as possibly can. So the CloudFront will store the static files as much as it can. This basically covers the point 1 of the solution, which says store and cache the static content as much as you can. Now, a really important part is going to be this configuration right here. The cache policy specifies what header are going to go through the CloudFront to the origin. So in case we have CloudFront in one part, we have the origin right here. We create a Lambda function in the middle, and those headers, such as CloudFront viewer country, is going to pass through the Lambda. The Lambda is going to see it, and based on this header, is going to specify either to go to US East 1 or US Central 1. So this is a very important configuration block. Now, the CloudFront distribution. We specify the first origin, which is going to be the default one. And the default one is going to be the S3 bucket. We specify a dynamic block through Terraform. You can specify a dynamic block, and if you have multiple variables, then you can make it look shorter, let's say. But in case you do not specify this dynamic block, you're going to set up for each API gateway, one by one, this kind of block of origin. Dynamic block is going to add all the API gateways as origins to the CloudFront distribution. We specify also the default root object, which is going to be index.html, since we have index.html for our website. Now, default cache behavior. Default cache behavior is going to be the latest cache behavior that in case the CloudFront does not find which of the behaviors you're going to go to, then the default cache behavior is going to be triggered at last. So at last, it's going to trigger the S3 bucket. But what we do in here, we specify that Lambda function, which is going to be Lambda function at edge, and it will be as event type origin request. Meaning, if you have the CloudFront right here and you have the origin right here, the origin request is the link between the CloudFront that it adds the header and right where it goes to the origin and connects with it. So the Lambda is going to be in this middle. If you specify other event types, then the Lambda is not going to work in our use case, such as viewer request. So the viewer request is in front of the CloudFront. So in that moment, if you specify it like that, the Lambda is not going to find the header. The header is inserted by the CloudFront. So the origin request, this is a very important configuration right here, needs to be done on the origin request. We have a dynamic block for the ordered cache behavior. And for each local API gateways, if we open the API gateways on locals, we say that for each region, we have the endpoint. So meaning that the path pattern is going to be the first two characters of the name. So basically it's going to be US, EU, and AP. If the path is /US/API/star, so whatever comes after API, then you will insert it to the API gateway of the US East 1. And since this is dynamic block, it's going to work for all of 3 endpoints that we have. And we will see later on how that looks on the CloudFront distribution behavior origins. We have also the restriction, that restriction type is none, and also viewer certificate, which says default certificate of the CloudFront. So this is all for the CloudFront distribution configuration. So since we have everything ready, then it's time to deploy. So let's go to lambda.edge and Terraform init. It is already initialized. Terraform validate and Terraform apply. Risk it. So the configuration is starting, 37 resources to add. So let's see on the AWS console what we are going to deploy. Let's start by going to the website. S3 bucket. The prefix, by the way, it is ustai. I've set the prefix ustai, and we are on North Virginia. Ustai bucket. We have the index.html and also the static files right here. Now let's go to the Lambda or the dynamic application. 30 seconds ago, we have created our application Lambda and also the Lambda edge redirection. We'll see it later on how this Lambda works. Ustai Lambda. Let's see the code, which is basically just going to respond with a region. And on the configuration, we have the environment variable, which is US East 1. See how it is going. So it is creating the distribution. We also have the API gateway. The Ustai API US East 1. And the integration is the Lambda that we just saw. And in case we want to trigger it, it says region US East 1. And also it is also deployed on the Singapore. So let's go to the region of Singapore and see the API gateway there. So it is right here. You can also trigger it, and it says the region AP Southeast 1. So the application works correctly for the moment. Let's go back to the North Virginia and let's see to the CloudFront distribution. We are creating it, it is deploying, and let's see what does it have inside. So first of all, let's go to the policies. The policies is the cache policy that we created. So it's going to be cache optimized with country header. And all it does, it enables the cache, and also it provides this header to go through CloudFront to the origin. So CloudFront viewer country. And this is what we're going to need it after. The TTL settings are on the maximum as we specified. And let's see the origins right now. So origins, we have 4 origins. The S3 bucket and 3 of our API gateway in each region. So behaviors. Now, the default behavior, which is the last, it is going to be our website. Those other behaviors are going to be just for the dynamic content in case of API calls to our application. So if we check the behavior of default for the S3 bucket, then we see the configuration that we specified on the Terraform configuration. So the cache is using cache optimized with country header. And for the origin request policy, we do not have any because we do not need. And we have on the function association on origin request, the Lambda at edge. So this is our Lambda at edge, and it is version 11 since I've already created and destroyed a lot of Lambdas. So the latest Lambda version that we just deployed. Now, in case you specify this Lambda right here on the viewer request, the Lambda will not find the header. The viewer response is going to be after the origin sent the response to the CloudFront, and the CloudFront is going to send it to the user. So you do not need that either. The one that we are interrupting is going to be origin request. And for other behaviors, such as US East 1, that's it. We have caching disabled because for the dynamic content, we do not want to cache any response. And on origin request, it's all viewer except host header. So we do not have any function associated with this origin. And we are ready to test it. Let's get the distribution URL and let's open. So such a wonderful website. The website is stored in EU Central 1. What happens in the background? Let's inspect it, let's see the network, and let's refresh it. So we get the first home page or the root directory or the index.html. And what it does, it collects the app.css and app.javascript. Now, it sends a request to the API region. It needs to find the region where the application is stored. And the application responds with a 301 permanently moved. Now, let's get very complicated. And when it moves, it says that the new location is going to be EU API region. Now, it sends the call on the EU API region and it responds with the status 200, which means it got the region of EU Central 1. Now, on the behaviors, since it calls the API region, on the behaviors, we do not have any path pattern of API/region. So it's going to get redirected to the default behavior, which is going to be the S3 bucket. When the request is redirected to the S3 bucket or the default behavior, there is the Lambda at edge. So the Lambda at edge, if we check the code, it will get the URI, which is API/region, and it says, if it starts with API, then get the header. The header, if it is not specified, it is going to be by default US. Now, my header, it is IT, because I'm in Italy. Since it is IT, then the region is going to be EU. And it redirects me to this /EU/API/region. So it sends the status of 301 and it says moved permanently. When the browser gets this request, then it knows that this endpoint is not there anymore and it has moved, so it will redirect the request to this new API. This is what the Lambda function at edge does. And since the API is moved and it is going to be on /EU/API/region, then the browser is going to send the same request again to the CloudFront, and CloudFront will check. Since we have the path pattern, which is EU/API/*, so the region is inside of this path, so the CloudFront will redirect the request to the API gateway of Frankfurt. And when this API gets triggered, it's going to run the Lambda function on the region of Frankfurt, and it will respond with the region itself, meaning EU Central 1. And the application, the JavaScript, is going to insert this region into the page. So this is how CloudFront manage to work with multiple regions, and the Lambda at edge checks the header and specify which region is going to redirect it to. Now let's see what it would be for an instance that it is at the moment on North Virginia. So what I have done is that I've created an EC2 instance, a small one, on North Virginia, which is running. So let's connect with it. Let's go to downloads and run the code. Yes, and we are inside of this instance. Now, since JavaScript does not work on terminal, then we will do a command that says curl -l, meaning the location, and also the CloudFront. Now, if we do it like that, then it will just respond with the index.html, but without the region. So, since we know the API call, where it's going to be on API/region. And what it will do is respond with the region US East 1. And for our use case, if we do the same command, so if we copy the command, since we are in Italy, it will respond with EU Central 1. So we managed to deploy in multi-region. We have the same frontend, basically stored on S3, and every static content is cached on our CloudFront distribution. And the Lambda at edge specifies where you're going to be connected with. So I will be connected with that region that the latency is the lowest, meaning Frankfurt. Recap time. As you saw, we managed to deploy a multi-region application and front it using CloudFront. We managed to store the static content and cache it on CloudFront, And for the users, we would redirect the request based on their origin using Lambda@Edge. If you are learning for the Solution Architect Professional exam, probably you will need extensive work with CloudFront. And this kind of project would help you understand on how CloudFront works and all of its features. And in case you missed my previous video, you have one right here and one right here. They both are projects for Solution Architect Professional, so you will learn more for the certification. Like and subscribe and ring that bell notification. Bye bye.